Okay, then if I share screen?
So go ahead and share the screen. So welcome everyone to the Ontology Summit 2023. Today is the 8th of February, 2023. And the topic today is the Ontology Development Kit. The speakers will be introduced today by James Overton. So, James.
Hey, thanks, Ken. Yeah, I'm James Overton. I'm one of the co-organizers of the Ontology Summit, along with Gary Cross. And today we are very lucky to have a bunch of people presenting on the Ontology Development Kit. Nico, Damien, Philip, Anita. They are all critical members of our OBO technical teams and keep things running and get the tools and infrastructure up and running across OBO. And I really appreciate their work. They've done a bunch of work to present the ODK, which is foundational to how OBO works these days. And I think it'll be really interesting to people outside of OBO who haven't heard of it before. And if you have used ODK, I bet you'll learn something new anyway. So Nico, Damien, Philip, Anita, go ahead, take it away.
Thank you very much for the introduction, James. A small warning, the session today will be longer, and we have aimed to do it around 1 hour, 15 minutes, but it could be a little bit longer than that. In case you can't make everything after the hour, obviously we have everything recorded and you can later on check the videos. All right, so let's get started. So just to dive into the kind of subject matter again, when we are building ontologies, we are very frequently faced with a situation where we want to define terms with I hear some noises. I don't know whether it's from me or someone else, but if this could be muted, that would be great. Where we want to define terms using often quite complex logical axioms. So here, for example, this is an example where we have a term like hypolysinemia that is defined in the human phenotype ontology in terms of a bunch of logical axioms that refer to classes from, in this case, just 3 different ontologies. So the Pato ontology that is dealing with phenotypic characteristics. So here we have the decreased amount term, and then we have a term from the Cabby ontology, which is lysine, and the Uberon anatomy ontology, which is blood. Now this is already pretty clear. We have already we need terms from 3 different ontologies here. And these kinds of axioms can become quite complex, but this is not nearly the most complex thing that you will see. So there are some axioms that are way even more involved than this, with even more entities that need to be dealt with. So here, the situation and the first question that we typically have when we are building ontologies is, how do we actually get terms from external ontologies to reuse them in our ontology? So we have our little ontology here in the middle with the hypolysinemia concept, and then that are linked to lysine, blood, and decreased amount. But how do we actually get the blood term from the Uberon ontology into our ontology so that we can refer to it, that we can use it, and that we can reason with it? And then as a second question, let's say we can do that, but how do I make sure that whenever I do make a change, whenever I do provide axiomatization as complex as the one above, or even more complex, how can we be sure that we didn't break anything in the ontology? Does it make sense what we are saying here? So we want some kind of testing mechanism that it gives us continuous feedback about the kind of content that we are adding to the ontology. And then how do I make sure that all users of the ontology can access the ontology in a standardized and fair manner? So you know that groups like the OBO Foundry, they provide, for example, principles that mandate that an ontology is released in a certain format, in a certain form, using a certain set of annotation properties. that help us to create an environment that allows us to, combine multiple ontologies and access them in a similar fashion, but also have them in some sense, in some way, interoperable. So now, what is the ontology development kit? So fundamentally, the ontology development kit is two different things. Probably would be good to have two different names for these two things, but they are both called ODK. So we have the ODK toolbox, which we will hear next about, which is essentially a way to combine all the kinds of tooling that we need to build and build these kinds of ontology workflows, such as Robot and Oak that we heard about last week, but also other tools like Make, Bash, different kinds of reasoners, and other specialized ontology tooling in one place. So rather than having to install many, many different things, you have one place to access all of these tools at once. And then the second big thing that the ODK is, it is also a workflow management system. So what does it mean? It allows you to use standardized executable ontology workflows that support all of these questions that I just outlined before. Like it supports you at importing terms from external ontologies, or it supports you to release your ontology in a standardized, fair manner. So how does it work in general? So the kind of like the overarching technical, let's say, framework on which we base these like workflow system is a version control Git repository that is being generated from using the ODK, a standardized layout. So if you use the ODK, the first thing that you would do is you run a command, and we will hear a little bit about this later as well, how this works. That allows you that creates this kind of like standard layout. And then this standard layout allows you then to execute all these like nice standardized workflows, which we will also learn a little bit about. So here, this is one overarching workflow, which is the workflow that we call dependency management. So here we want to have repeatable workflows like refresh Uberon that allows us to not just import, like copy paste the blood term from Uberon into our ontology, but actually go check at the Uberon ontology, maybe this term changed, maybe some axiomatization around this term changed. And we want to make sure that our ontology is always current with the axiomatization in the upstream ontology. So there are many different module extraction techniques that are already supported by ODK. And then we have this continuous integration testing, which is an answer to the question, like, how do we know that everything we did actually worked correctly? So we have a system that can be integrated in GitHub, but I think also in GitLab, we also have a draft that it works as well, that allows us to, if you are using such workflows like GitHub workflows, to actually just whenever you make a change to your ontology, you make a pull request in the normal way on a Git repository, and it will run a test, a phalanx of checks, like making sure it's consistent, making sure there are no unsatisfiable classes, making sure that all of your custom checks, which we will learn in the end, towards the end of the session, are all covered and are all passed before you then can be confident to merge your changes into the master branch. And then the release workflow, which what it does is you have like an ontology that is somewhere in your repository that is the designated editors file. So this is the file that you, for example, edit with Protege, or edit with robot templates, or edit with whatever other system you want. And the ODK will go and then turn this editor file or multiple editors files into various standardized variants and potentially subsets that can then be used by your users and accessed by your users. So there is a repeatable workflow to run a release pipeline. supporting these, what I said before, standard serialization, standard variants, and of course, all the kinds of principles that have been suggested by the OBO Foundry for like versioning, but this is not just, this is independent of OBO. This can be used for any kind of sane, let's say, ontology system. All right, and then, yeah, this is also just a side thing that we sometimes show and sometimes not. I find it super cool, so I just show this slide. There's also a system embedded in ODK that allows you to generate super quickly your own documentation website that is hosted on GitHub pages straight away. And you can customize it yourself so that you can have some kind of website that is user-facing, where you explain how to use your ontology, and where you have the documentation for your own editors, how to execute and manage your ontology repository as well.
How can you do it?
Yeah.
With that here, I want to make a brief quick pause. So after every session, we will do 2-3 minutes questions, but not more. We need to move on, but we will have a larger slot towards the very end where we can do a little bit more. So I just want to acknowledge the team and some of the core funding. Here we also have a paper that was recently published in the database. I don't know why we have the archive link here. It should be updated. And yeah, so if you have any general questions right now, you can ask it. Maybe 1 or 2 questions we have time for, and otherwise we will move over to the. I will actually unshare now, and Damien, you can share your screen in the meantime.
Sure.
No questions, great. So then let's go to Damien, and thank you.
Sure. So can someone quickly confirm that they see my slides?
Yeah, we see your slides, not in full screen mode, but in good mode.
Okay. So hello all. So I'm Damien. I'm somehow a core ODK developer, and in this small presentation, I will explain what the ODK toolbox is. So one part of the ODK that Nico alluded to is, and how to use it. So let's start by addressing first the question of why we need a toolbox to begin with, and why we choose to provide it the way we did. So people working with ontologies typically need to use diverse collections of tools, which are written in many different programming languages, and each of those tools can depend on an even more diverse collection of software libraries. And we need those tools to work across several operating systems. At the very least, they need to work under Linux, macOS, and Windows, which are the 3 platforms used by most ontology editors and developers. And we also need them to work across several computer architectures. At the very least, we need them to work on x86, which is the typical architecture of a typical PC. And nowadays, we also need them to work on ARM64, which is the architecture used by the newest Apple machines, and also by some more exotic machines such as Raspberry Pis. So asking users to install all these tools by themselves is not really an option. There are just too many of them, and their installation may sometimes require technical skills that not all ontology editors are expected to have. For example, programs written in compiled languages such as Rust or C++ may not be available as pre-compiled binaries for your precise combination of operating system version, and computer architecture. So in that case, those programs may need to be built from source, but not everyone knows how to build a program from its source code. Programs written in Java, depending on how they are built, may or may not include their dependencies, and they may require the installation of a Java runtime environment if such an environment is not already available on your system. And some Java programs may even require a specific version of the GRE, which may be different from the one that may be installed on your system. For Python's programs, they can theoretically be installed simply with pip, but let's just say that whether pip is part of the solution or part of the problem is anyone's guess. So overall, we simply cannot give our users simple instructions that they will just need to follow in order to get all the tools they need. So one possible solution would have been to use package managers, as is done on typical GNU Linux distributions. This way, we could simply instruct users to just use one command to install a single meta package, something like apt-get install Ontology Essential on a Debian-based system, and that would automatically install all the tools they need. So that would indeed be great, and I would personally love to see that, but unfortunately, there is no such thing as a universal package manager that works across all systems. So we will need to provide packages for, just for GNU Linux, we will need to provide at least deb package for Debian-based distributions, RPM packages for Fedora-based distributions, possibly PKG build scripts for Arch Linux-based distributions, and so on. For macOS, there are at least two competing package managers, MacPort and Homebrew, and I'm not even sure on what is exactly available for Windows. So in the end, the solution that we chose was to provide the ODK toolbox in the form of a Docker image. So without going into too much details, Docker is an OS-level virtualization system built on top of the Linux kernel. And such a system allows to run processes that are isolated from the rest of the system. And such processes are set to run inside a container. A Docker image is basically a representation of a file system that contains all the files required by any given application to run inside a container. Simply put, the image contains basically an entire Linux-based operating system, except the Linux kernel, which is provided by the host system. So Docker images and more generally containers, there are other containering solutions beyond Docker, but Docker images are nowadays used for many applications. But for us, the nicest thing about them is that they can be used on any system where you can run a Docker daemon. And the Docker daemon itself can run natively on any GNU Linux system. And now it can also run on macOS and Windows, thanks to a program called Docker Desktop. So we thus made the ODK toolbox as a Docker image called ODK Full, which is basically an entire Ubuntu distributions augmented with all the ontology manipulation programs ready to use. So not only is the toolbox quite easy to install that way, as we will see in a moment, but it also ensures that everybody is using the exact same versions of every single piece of software and all their dependencies. And that greatly facilitates troubleshooting and debugging. So what's in the toolbox exactly? So we actually provide two different Docker images. The first one is called ODK Lite. It's intended to be kept quite small and contains the most essential tools. So it's a Ubuntu distribution with the runtime environments for executing Java, Python, and Scala programs, and a small set of ontology tools such as Robot, DOSDP tools, all tools. And it also contains the ODK control script that is needed to seed an ODK managed repository, as Nico alluded to in his previous presentation, and as we will see in more details in the following presentation. The second image is called ODK Full. So that's typically the image that we talk about when we just mention the ODK image without any further precision. So that ODK Full image is built on top of ODK Lite. So it contains everything that is already in ODK Lite, plus some development tools, such as the GNU compiler collection, the Java development kit, and so on. And it also, and most importantly, contains an extended selection of tools needed to work with ontologies and graphs, such as, for example, the Ontology Access Kit, the OAK, and also the entire scientific Python stack, so including NumPy, SciPy, Panda, and so on. So how do you install the ODK? So that's actually quite simple. First, you need to install Docker. So on macOS and Windows, you just need to download Docker Desktop from docker.com and install it on your system. On GNU Linux, there are several ways to get Docker depending on your distribution. I won't go into many details. once Docker is installed, you just need to make sure the Docker daemon is running. Again, on macOS and Windows, you just need to start the Docker desktop application. Whereas on GNU Linux, you can configure your system to have the daemon automatically started at boot time. And then you just need one command to download one of the ODK images, the one that you need. So by running a command such as docker pull obo library /odk full or odk lite, depending on the image that you need. So now in the rest of this presentation for the remaining few minutes, I will explain how to use an arbitrary program from the ODK toolbox independently from any ODK managed workflow. And very importantly, the following slides are merely a live version of a tutorial that is available in the Obo Foundry book at this address at the bottom of the slide. So if you miss something or if anything is not entirely clear in this presentation, I invite you to check this tutorial if you have not done so already. So here is the basic way of invoking a program that is part of the ODK toolbox. So you use the docker run command to start a container from a specific image. So here's the obo library /odk full image. And at the end of the command line, you simply call the program that you wish to invoke with its arguments is needed. So here, for example, in this example, we simply check which version of robot is available in the toolbox by calling robot -- version. So the command will run, produce the expected output, then the container will terminate, and you are returned to your original shell prompt. Oops. Sorry about that. So one thing that is important to remember is that processes inside a container are isolated from the host system. And that's normally the entire point of using containers in the first place. But in our case, most of the time, you will want to invoke an ODK program in order to do something with your ontology files. This means that you need to somehow break the isolation layer between the container and your machine to allow the program you invoke to access your ontology files. So this is done with the V option here. So this, when you call docker run, this option binds a directory from your system to another directory within the container. So in this example, we bind the current directory, which is represented by the shell variable pwd, to the work directory inside the container. This means that any file in the current directory will appear to be in the /work directory inside the container. And in addition to that, we also instruct Docker to start the command in the /work directory using this -w option. And when those two options are combined, the program that we invoke here will be able to read and write files in the current directory. So as in this example, when we ask robot to convert the in.obo file, which is presumably located in our current directory, to convert it to an out.ofn file in functional syntax. So sometimes you may also, for now, we've seen a way to invoke one command and then let the command run and let the container terminate. But sometimes you may want to invoke several ODK programs in a row. So of course, in order to do that, you could simply just use several Docker run commands in a row, once for every command you want to run. But sometimes it may be more straightforward to start an interactive session within the container. So to do that, instead of asking Docker to run an ODK program such as robot or DSDP tools or all tools, you ask it to run an interactive shell, such as, for example, bash in this example. So the shell will start inside the container, and when you are in that shell, you can run as many commands as you need using any of the tools provided by the ODK. You no longer need to prefix all the commands with the Docker run instructions, since you are already inside the container. So for example, in this example, now that we are inside the container, we chain two commands. We first use robot convert to convert an obo file into a file into another format. And then we use the conclude reasoner to check this converted file for consistency. And then once you are done with what you wanted to do, when you no longer have any command to run, you just exit the shell to terminate the container and get back to your real prompt. One thing to note if you do start an interactive session is that while you are inside the container, you no longer have access to any of the programs that you may have on your own system. You only have access to the programs that are installed in the Docker image. If you need to run a program that is not part of the ODK, but you have on your own system, you need to exit the container, get back to your real prompt, and run the command from there. And lastly, and as you have seen in the previous slides, anytime you want to invoke an ODK program, you need a somewhat complicated Docker run command with the correct set of options, such as the -v option and the -w options, to bind your current directory to a directory inside the container. So this can rapidly become cumbersome, and this is why the ODK provides a wrapper script to hide most of this complexity. So if you already have an ODK-generated repository, the wrapper script is located in the src/ontology folder under the name run.sh. So you just need to run that script followed by whatever command that you want to run, such as, for example, here again, the robot command. If you want to use a program from the ODK toolbox, but you do not have an ODK-generated, an ODK-managed repository, then you can either download a pre-made wrapper script from this page here, or you can even come up with your own wrapper script. It's quite easy. It can be as simple as 2 lines bash shell script, just to wrap the Docker run command and to adapt it to your particular setup. And with that, I am done with my presentation of the ODK toolbox. So as Nico said, I'm happy to take 1 or 2 quick questions before leaving the mic. Not sure if it's Anita or Philippe who are following now. I will stop sharing anyway.
Thanks, Damien, so much. Yeah, any questions? 1 or 2 quick questions?
My simple question is there a list of commands available through a help command or question command for the new or users?
So no, in the container itself, there is no there's no way to get a list of all the commands available. There is such a list in the paper that we published last year, but there is no definitive list, a single source where you can find all the commands available on the inside the image. That could be quite a nice addition, actually. And thank you for pointing that out.
Welcome.
Okay, I guess I start then.
Sure, please go ahead.
Okay, thank you. So first of all, I became an ODK user because I needed a good solution for several ontology projects I'm involved in Germany's Library of Science and Technology, TIB, and more concretely in the ambitious National Research Data Initiative that is NFTI for Chem. And I've learned about the ODK, how to set it up and use it for such ontology repository projects by reading the documentation, looking at parts of its source code, and asking curious questions in its community spaces. So when Nico asked me to give you this talk today about how to set up a basic ODK-based ontology repository, I was happy to agree to give something back to the community. As Damien just said, the main thing that you have as a prerequisite is to have Docker installed. So you can easily download the ODK container from the Docker Hub library. And also, since we're talking about Git-based repositories, you also need as a prerequisite to have either a GitLab or a GitHub account. We are mostly focusing on GitHub in this example. To interact with your repository later on. Also, in order to interact with your Git-based repository, you need some way to do that. So I am kind of like the GitHub desktop guy because I'm more a GUI person and not command line savvy. That's what you need. And having just heard about a wrapper script, there's also another prerequisite, which is the seed wrapper script, which you will need in order to create a ODK-based ontology repository from scratch. And you can just download this from the ODK GitHub repository, depending on your operating system, either for Mac and Linux or for Windows. And then you just save it in a temporary directory, which will be the place where ODK saves its first output to when you start from scratch. And later on, you will take this output and copy it somewhere else. So with those prerequisites set up, all you need to do is just follow 3 steps, and then you can start maintaining your ontology in a repository the ODK way. And actually, it's only the first of those 3 steps where you need to do some thinking, I think. So, because in that step, you will have to configure some basic configuration parameters of your ontology project in a human-readable YAML file. And then in the second step, you will pass this config YAML file to the seed wrapper script. You just download it and let ODK create a complete Git repository for you. That means it will automatically create all the files and directories that you will need to start working on your ontology project. And then the last and third step, which is very easy, that's the only step left to do, is to upload that created repository to GitHub or GitLab. But now let's have a closer look at those 3 steps, and especially the first one. Here you can see parts of the configuration YAML file that you need to create. And the purpose of this YAML file is to provide key information needed by the ODK at various other steps in its workflows and pipelines. For example, the ID and title parameters are used to define the general metadata of your ontology. Those 2 fields are thus mandatory, and they are being used to build, for instance, file names and term IDs from the ID field, or the title is used in other template-based values by the ODK. For the ID field, it is recommended to use a rather short and all lowercase ID by the OBO community because it's easier down the road. And there are, of course, other optional metadata parameters that you could have, for instance, to provide a description or a list of the creators of your ontology with which ODK could generate respective DC terms ontology annotations. But for brevity, I'm focusing here only on the required fields. The next 3 important fields you need to have in your config YAML are GitHub org, with which you set up the GitHub or GitLab handle under which this repository is supposed to live. And if you leave this empty or don't provide it at all, ODK will default to use the Git username and email it fetches from your operating system. Repo is used to set the repository name you want to give your project on GitHub or GitLab. And if you plan to use ODK to migrate an already existing repository to the ODK solution or to the ODK structure, you need to use this existing name for that repository here. And with Git main branch, you can set the main label, the label of your main branch, which is also mostly relevant when you're trying to migrate an existing ontology repository, and there your main branch might use something else as a label like master, for instance. Main is the ODK default. Now, coming to the parameters that deal with types and formats or serializations, as Nico mentioned in his talk, there are what we call release artifacts, and the list parameter for that called release artifacts, there you can tell ODK to generate different types of releases, with each of these types being a different set of axioms of your ontology. Full, for example, is the most common type that contains all logical axioms, including inferred subsumptions. And with base, on the other hand, you could serve only the native axioms of your ontology, thereby avoiding problems of possibly outdated or incomplete external imports. And ODK currently supports 6 different types of these release artifacts, and you can find more details about this on the OBOK documentation page that is listed here. And with primary release, with that key, you can set which of these 6 possible types should be your main release artifact. So like the obi.owl. And full is ODK's default for that one. And with regard to formats and serializations, you can use the export formats list parameter to provide a list of formats and serializations you want to have your release artifacts in, such as RDF XML, you just use OWL, or TTL or obograph JSON. And the next thing you'll most likely want to set up in your config YAML are the ontologies you want to reuse within your project. So for OBO ontologies such as Row or Pato or OBI, you can simply list their IDs under the import groups products list parameter, and then ODK will download them automatically and build import modules from them with the terms you need to specify a text file somewhere else. And for non-OBO ontologies, you can add, for instance, the mirror from key to one of these list items, and then provide the URL as a value from the URL from which you want to download that non-OBO ontology. And also there are other parameters, for instance, module type, where you can further customize your import modules, but we will see in a later talk how that is being done. And finally, even in a very minimal config YAML, it seems wise to specify how much RAM should be allocated to robot, which is used heavily within OBO-based ontology repositories. And you use the robot Java args parameter for that. But please make sure to have at least 20% more RAM available for the Docker image itself. And of course, other robot parameters could be passed with this string value as well. And of course, there are many other more parameters that you can specify in this configuration YAML, but those are the ones that you need to get started quickly. And if you're curious like me, you could check out the examples I've linked here, or you can look at the ODK source code. And as I've said, now with the config YAML already, all you need to do is pass that config YAML to the seed wrapper script with this one-liner you can see here, and then ODK will generate a complete ontology Git repository for you with all the needed folders and files. And this is great because it just not only saves you a lot of time of thinking about how to manage and set up your repository in terms of structure and everything. The great thing is that it also makes it easier for you to contribute to existing ontologies that are using an ODK-based approach, because you can rely on this standardized structure. You know exactly where to find what and what does what. And as you can see here on the top level, you see the release artifacts and the formats they are serialized in as specified in the config YAML. And of course, the most important folder, which is the source folder that contains your ontology source code. And if you look into that, then you can see 4 different folders. The metadata, ontology, scripts, and Sparkle folder. The metadata folder is only of relevance for you if you wish to submit your ontology to the OBO Foundry, because it then automatically contains all the metadata that is needed for that step. But most importantly, there is the Sparkle folder, which contains the queries that are used in the quality control pipelines that come with ODK, and where you would put your own Sparkle queries for your own quality control pipelines. And similar in scripts, you could add scripts that you want to use for customization. But most importantly, of course, is the ontology folder, because that's where the magic happens. This is where your ontology editor file is located. And then I forgot there's the Yeah, in there you have the reports folder where reports that are generated during quality control checks by robot, for example, are stored, and you can then look at them and see what went wrong and what went right. And the seed rep script also makes a copy of your configuration YAML file and places it in the ontology folder, because when you want to add new parameters or change parameters, that is then the place where you would do it on that configuration file. And of course, as we've heard, there is the run.sh or run.bat, depending on your operating system, the wrapper scripts that you will call to invoke the commands that ODK gives you to do the stuff you want to do. And those commands are defined in this auto-generated make file. You shall not change that, and it will be automatically overwritten if you update your ODK. If you want to do some customization, there you have a project.make file, like in this case, the cato.make file, where you can do some customization. So once you have this repository seeded and generated by the ODK, as I said, we're coming to the last step. All that is needed now is to upload this repository to GitHub, and preferably you want to move it someplace else on your system in a place where you want to have it to live, and move it out of this temporary seed directory we set up in the beginning. And as I said, I'm more this GitHub desktop kind of guy, the GUI guy. So for me, it would be just a matter of clicks, adding this repository and uploading it to GitHub. But the seed wrapper script also gives you some instructions how you would do this on the command line. So having told you about the most important steps that you need to do in order to get an ODK-based ontology repository, I would now like to say just a few words about why I think it is very, very good and a good idea to use such an approach for the ontology development and maintenance, because as Nico mentioned before, the most important feature I think is that with an ODK setup, you can manage your imports dynamically, so that all you have to do is simply add a term IRI to a text file and then call the ODK command make refresh imports, or make refresh OBI, for instance, for that particular ontology import module, and then it'll update your import module and you're done. And this makes it very easy to be up to date and keep your imported dependencies up to date, and minimize the risk of using obsoleted terms or axioms, which is really, really cool. And of course, another very cool thing why I like to use the ODK is that I don't really have to worry that much about making a release and thinking about steps that I would have to do in the middle, like making sure that the ontology is logically consistent, and have other checks that will maybe tell me that I have missed to define a term here and there, or maybe I have double labels. Such quality control commands are bundled within the prepare release command, so I can just type make prepare release, and this pipeline will be run. But of course, I could run such quality control checks in the middle as well by maybe running make test or check validate profile to make sure that my ontology is within my desired OWL profile. This really helps in the daily ontology editing and maintenance. And especially when working with Git, what is really great is that ODK comes with an automatic workflow for GitHub. It's not that hard to adjust this for GitLab, I suppose. And what this automated workflow does is making sure that whenever you do a pull request, the quality control pipeline will be run, and it will check. And if there is an error, then it will let you know, so you can make sure, check this error, fix this error before you make your actual release. And this is really, really helpful, because it makes ontology development and maintenance more like software development, and making sure that your release is proper and right. And the quality control scripts that are in the ontology development kit already are geared, of course, towards the OBO principles, but I think they are very helpful already, even for non-OBO projects, and we will find out in the next talk. They can always be customized and geared towards what you have for needs. So I hope with this I have been able to wake your interest in using ODK for your next ontology project, or maybe think about how to migrate an existing ontology project to an ODK-based setup. And don't worry if you still have many open questions for which we do not now have the time, because there's great documentation within the OBOK that is linked here, and you can find comprehensively written how-tos or tutorials and references. So please make sure to check these out. And with this, I thank you for your attention and would like to give it up.
Thanks, Philip. Maybe a quick question, and then we'll move on to Anita.
Just wonderful. Okay. Wonderful. I see the attempt that you are making as a team to make ontologies more robust and usable on a common platform. So that's a great effort. Thank you.
Thank you for the presentation. That's really nice. I just have a question. When you import external ontology, you're using the release version or development version?
This is you could do both, but of course you would use the release version.
Okay.
From the imported ontology, like when I say you're importing an OBO ontology just using the ID parameter, like OBI, for instance, it will always fetch the ontology behind the Perl of OBI. So, but okay, so if you want to specify some other version, you can use the mirror from parameter and then provide the Perl or the URL for that version.
So the default is a release version, right?
Yes.
Okay, thank you.
Great. Maybe we will move on to Anita's section.
Okay. So now we have a bit of a practical part. So yeah, here I have set up an OTK repository ontology using OTK, and yeah, a version of the cat anatomy ontology. And actually, I want to show you how you can create and add the custom Sparkle query into as a unit test in your ontology. So the custom Sparkle queries in OTK is an extension of the Robo report that James explained last week. So all the general tests are already done in the Robo report, but then, as we all know, each ontology is unique and needs all some specific tests for your ontology, and you can use this for you can use the custom Sparkle query here. So, for example, you can make any type of test for your ontology. For example, if to make sure that all created new classes in the ontology are a subclass of another specific term, or you can go just check to all annotations. For example, here the creation date, they have the data type as a SSG date time. So this is what I'm going to show you, how you can create a unit test for to check this. Here is a simple example, but then for your ontology, you can create as your need. So here, yeah, I use the the class in the cat ontology, and then I have this annotation. So first, what we need is to create the Sparkle query. So here we can think of this Sparkle query as a unit test. So so we need to write this query to identify the error, and then this is more like a int pattern. So we don't want to have a result for this query. If we have a result, it means that something is wrong. So here in this, to test the all annotations of the creation date is of the type of date time. So I have to filter actually all the values of the creation date that aren't the date time. So we need to do the opposite to find the error that we want. So okay, so the first step is actually to create the Sparkle query. Then we have to simply add the name of the file here into the configuration of the ODK. So here, as I said, the custom Sparkle checks are part of the robot report. So first we specify the robot report configuration, then we include the parameter to custom Sparkle checks, and then just add the name of the file without the violation. And then we can actually we can list here as many as unit tests that we want. And after that, we just we update the repository. So then it can apply this check and then include this test into the pipeline for the test after in the pull request and so on. So locally, you can, if you want to test locally before you see in the pull request, you can just run the Sparkle query command, and then it's going to run only the custom Sparkle checks. So here we can see that actually it failed. So it means that this creation date is not of the type of the date time. So we need to fix it. So we just go here, and then we see that it's a string. So we just go and fix it. Save it. And then we can try again to see if everything is fine. And then we see here there is 0 violations. Yes, so in ODK also we have already defined a list of checks. I can give you already after the link of listing all the checks, but easily we can just, for example, we have a check for to check a redundant subclass of. If we just need to paste the name of the check, update the report again, and then run the Sparkle test command, and then it doesn't work. And I didn't save the file, sorry. Need to save the file always. That's important. Yes, see now, So here we see the two checks that we just added. So you can add as many as you want. Thank you.
Excellent. I think I can't believe that we made the 60-minute mark. I thought we would be way over it, so this is great. But we do have 5 minutes if anyone wants to ask any questions to any of the things we've heard before, to Anita about customization, to anyone else. So if you just feel free to use the time.
Anita, we saw quite a bit of complexity in your presentation. The fact whether the file came back successfully with output in SQL query is another question. But the complexity of several screens and then finding what went wrong, can that be simplified, you think, in the next versions, so that we look at the protege kind of file that you looked, and then prompt the user with every error, they put the date in this format and so on, rather than asking them to search that field where error went. Namely, only prompt them on exceptions rather than what goes on well. It's just a suggestion.
Yeah, thank you.
Mm-hmm. Great series, very good linked presentations. Thank you, James and others.
I think your question is really, really important, Ravi. I just want to make another comment to this. So it is true that, Anita just showed how this test would be run locally, and only a tiny fraction of developers actually ever run the tests locally. Like 99% will always have these like GitHub sort of workflows where it will just be green if everything is fine, and if there is something bad happening, they will just get like a red test, and then it will print out the last rows just before that specific test that failed, and you just look at the last 3 lines and okay, that's the reason why it failed. So that's the one side, but even that is for some people still a problem. And you're right, Ravi, that a better integration of our validation pipelines into the tools we are using to edit your ontologies is a hugely important subject. And I think, like, for example, a lot of tools that James is building for the next generation of ontology developers actually have this as like a design principle. So we want editors, table editors, ontology editors that tell you right away if something goes wrong, and they highlight exactly the cell, exactly the class. That is where the mistake happened, and this is, I think, this would be a great sort of evolution forward to have ODK a bit more embedded in workflows that are more close to the actual curation portion of the work. But we are a good way away, unfortunately, from that kind of integration so far.
Well, everything takes time and iterations. And you certainly have conveyed today that there are different parts for using, reusing, and versioning ontologies. And there are errors to be handled. There are metadata to be pre-populated, or somebody using it should think of metadata, among them which ontology to use, which version to use. So many things you have told us that we as ontologists normally do not think of. And also specific to biodiscipline, you have brought very good integration of different parts. Still, there's a lot of room, and some of it I see using as software, agile kind of development environment to go on improving. So it's fantastic. It will take some time, but you will reach there where I suppose I don't know Python. I can barely remember my shell commands from GNU and Unix days and so on. So you are bringing old users or uninitiated users to using the ontology by providing them the right tools and the platforms. Thank you.
Thank you, Ravi. That was very kind words. Thank you.
I just want to throw in my 2 cents. abusing my position as the host, but yeah, I feel like a decade ago, OBO projects were mostly edited in Protege or OBO edit by hand, and we'd save the files, and then every once in a while we'd run a reasoner and we just kind of throw them over the wall and publish them. But I feel like what we've accomplished in the last 10 years is adopting workflows and best practices from software development and reusing open source software development platforms like GitHub and automating all this stuff, wrapping it up in Docker containers. And we've made our ontology developers in the OBO community far, far more efficient, productive than they were before. We can handle much bigger projects. We can generate higher quality artifacts. And then the trick is to kind of close that loop and get back to the point where we were when anybody who could use Protege could edit the ontologies. These days, the learning curve is much steeper. But yeah, it's definitely one of my personal projects to get back to the kind of ease of use that we had a decade ago without losing any of these advantages of automation and quality control. And Alan was in the chat, he's saying, it looks like VS Code to me. Yeah, Anita was using VS Code for editing the Sparkle query. And yeah, we do tend to use Protege for editing the OWL files, but there's lots of template-driven stuff, as I talked about last week. It's definitely part of ODK. And we do, so a lot of template-driven validation, and a lot of our validation of like templates is a little bit maybe easier to use with the reports and stuff. We can get better feedback into the template sometimes. Okay, that's me rambling. Any other good questions? We are over time, but we could maybe stick around for a few more questions.
Mike Bennett had a question.
Thanks, Jane. Less a question, more a concern or a comment. So, Anita, I saw you did a test for redundant subclass relations, but like one of the advantages when you're building out an ontology in a conceptual domain is precisely the ability to slot in intermediate superclasses and subclasses without breaking your existing ontology. So, as we've seen with other like specific ontology testing regimes like OOPS and OQuare and so on, some of the specific tests that people would write are very nicely appropriate and fine-tuned for an application ontology, an OWL file that's going to be for a specific use case to do a specific job and provide a specific outcome. And some of those kinds of tests may also apply to an ontology of the business concept space, the ontology of the real things that's got nothing to do with data, and some of them may not. So just when you're designing processes around this tool set, whoever's designing that kind of process for a given project would need to take account of the different styles of ontology, have different namespaces to mark those out, and which bundle of tests are applicable for which styles of ontology. So less of a question, but just a thing to flag up, that otherwise you just go, oh, one thing's an ontology, and the developers will, being developers, will always think of as many tests as they can because they're interesting to do, but they may not always be applicable to all the ontologies you're looking at.
Yes, sure. Yeah, it's, I said, your ontology, it's totally up to you to do all the changes you want.
Yeah, writing the policy and strategy documentation for a specific project is going to become more and more complex and more important. That really has to start there. Thank you.
Thank you.
All right, any other questions? I think we're doing okay on the SoapHub chat.
I don't know if I answered the question Ravi had in this other chat. He was asking for how to handle compatibility with regard to using older versions of an ontology in import chains. As I said, yeah, you can use the mirror from key parameter and could then specify the URL of the older version that you want to use. So when you want to pin your dependency to a specific version that is not the version behind the Perl, you would have to have the URL of that version you want to use and pin it to.
But yes, thank you, Philip. That answered part mostly. But the remaining part of my question is, how do you make sure that the two versions, while integrating in further use of ontology, do not fail? Or if they fail, that the error files are trapped somewhere and then you are prompted? Does that happen real time, or you can run a batch, disappear somewhere, come back and see what happened?
I guess I'm not really following what you mean.
What I'm saying is, suppose you have two versions, older version and newer version. Integrating the two, some terms have changed and there is no incompatibility in vocabularies. So it fails for some reason. Are those reasons documented well enough in some error file?
Philip, can I answer this question? So I think that in our world, dealing with two different versions of ontologies doesn't happen in the same kind of space. But what we would do in order to handle a kind of like multi-version situation would be, for example, you could just simply create two branches on your GitHub repository, one with the one branch, one with the other, and that way monitor the QC related to the one version of the import ontology and the QC with regards to the other. So you would always see, does the pinned version work and does the latest version work, for example? They could do something like that. I have to say this has never happened in practice, but it's theoretically definitely a possibility.
I get it, Nico. I also get it that you will run two threads. Only point was, how do you integrate the two threads? And I think we will get there. Today may be too early, but in some stage of your development, you will find cross-connecting the provenance aspects. Thank you.
All right.
Good answer. Thank you, sir.
There's one more question in the chat, which is Alan asks, what's included in the documentation that ODK automatically generates the button ontology?
Okay, so the main things that are being generated are basically the editor's documentation. So this is kind of like the workflows that are customized to your ontology. How do you do a pull request? How do you run a release? How do you refresh the imports? How do you rebuild a component? Blah, blah, blah. So all of these kinds of things, that's like the one side. So you can see there will a few pages about that. There's a little bit about like on your repository. So it will tell you, these are the ontologies you import, these kinds of module types are you using, and this is where you import your ontology from. So this kind of information. And there are some additional features you can use to automatically document certain other things like a DOS-TP pattern that you're using and stuff like that. But that's kind of like the automatic part. The rest of the documentation is generated, you will generate by yourself. So that's kind of like where we see the scope of the automatic documentation part for ODK.
And then the published file, well, we expect it to be loaded into an ontology browser like OLS or OntoB. So if you want to browse the ontology content, you're going to look in one of those dedicated browsers, right?
Yeah, that's right. So we don't want to include a ontology browser in the documentation. It's theoretically possible with toolkits like Load and others that are out there. It's actually quite simple, but our ontologies on average are so large, there's just no point to create HTML pages for all of these ontologies. So we'd rather use OLS, OntoB, and our other browsers that we are using.
Mm-hmm. Or Ontology Access Kit if you're working with it locally in a dev kind of environment. All right.
Thank you. Are there versions of your development that are being used in the OBO community now as regular users?
Yeah, we have about 70 documented. You can see them in the paper also. They are listed at the end of the paper. I think there are about 70 documented usages, out of which I would say about 40 are very active and the other ones are like semi-active. Yeah.
Excellent.
And that probably covers 70 or 80% of all the terms in OBO, because it's the bigger projects that are using this powerful automation platform. So maybe even 90%, like most of the terms that you'll see in OBO touch ODK at some point, or something that it grew out of, like whatever, Go tooling pipelines or something. Maybe that's just talking, that's just a random guess, but it's a huge percentage of the big projects, especially.
Thank you all.
All right. I don't see any other questions right now. I'm thinking we should wrap up. So I'd like to thank Nico and Damien and Anita and Philip for all your work in this presentation, and everyone for sticking around for a few extra minutes to cover this like big topic. And we're going to, all these presentations we've been giving are really building on each other. So we talked about COB, which is like the upper level ontology to kind of coordinate robot OBO projects. Robot is the kind of foundation of OBO tooling, automation workflows. And then ODK builds on that to get even more powerful stuff. And we saw that today. Next week is going to be on dashboards, which are quality control checks. And Nico's going to be presenting on a bunch of stuff, and Anita. And I think Charlie's going to be presenting on his kind of GitHub related ones, right, Nico? Mm-hmm. So we'll get this updated. So yeah, dashboards, which give you an overview of how your ontology checks out on a range of different tests, but also helps us like get together on the same page as a community and coordinate all these things. And so yeah, it's definitely building on each week by week. So I'm really hoping that you can come again next week. Thank you very much for coming this week. And yeah, have a great week until then.
Very excited.
Thank you. Thank you.
Sure.
Thanks so much. Bye.
Thank you. Bye.